Hello, everyone, and welcome to SIG Scheduling Weekly Meeting. So today we have a few items. As usual, we are going to go with an update on some of the features that we would like to move to beta and other items that we have for 1.11. So let me quickly pull up this spreadsheet. Okay. I don't know if Klaus is present here. We would like to hear, let's see. I don't see Klaus. Yeah, so let me start with priority and preemption. So priority and preemption, I think it's on track. We have been able to find a real user, an internal GKE customer who has been using this feature for a while, and we haven't seen any issues in their clusters, which is a great news for us. Looks like the feature is working fine. At least when you enable it without using priority and preemption, it's not going to break your cluster. We were concerned about this particular scenario because we are replacing the scheduler's queue, and the mechanism of the new queue is quite different from the previous one when priority and preemption is enabled. So it could, even if someone doesn't use the feature, it could impact the cluster if there is a bug. So far, we haven't seen any. We are trying to get all of our E2E tests on clusters, basically running on clusters with all the alpha features on. There are some glitches there, but we believe they are not related to priority and preemption. So I guess right before the meeting, Jonathan was telling me something that could possibly be the key. Was it your conclusion there? Or?
No, I'm still trying to figure out if there's a particular go routine blocked.
Okay.
There's about 100 in the scheduler while it's idle.
Yeah.
And I was trying to identify which one was waiting for the queue.
Okay. Well, yeah. So we will know better soon, but so far we have not identified issues. There are several smaller items remaining. We would like to add some scalability tests with feature enabled. If we can get that done before moving it to beta, it'll be great. We should double check that our cluster bring up scripts or other tools that bring up a cluster will always bring up a scheduler as a part of the whole cluster bring up. I expect this to be the case, and I have once checked before. I'm pretty sure, I've already checked, and I know that Cube scripts already does that, but we would like to make sure that other possible tools do the same thing as well. And then there was one other item that Ravi was just before the meeting pointed me to, and I guess that's supporting multiple schedulers that have preemption support. So we don't have this support yet, although we don't feel like it's a critical feature before moving priority and preemption to beta. Basically, the idea here is that if there are multiple schedulers that support preemption.
Bobby, sorry to interrupt you.
Yeah, sure.
Are you recording the meeting?
Yes.
Okay, yeah, I'm sorry. I wasn't sure if you were recording it because for the last 2 weeks, I did not see them on YouTube.
The last 2 weeks, we didn't have any meetings.
No, I mean, before that, I'm sorry.
One of those weeks, my recording was broken somehow. I don't know what had happened. But anyways, the file was corrupted. But other than that, I guess I'm pretty sure it was the last one.
I'm sorry, this is for the gang scheduling thing. Is this the same one that was broken?
Maybe. I don't quite recall what was
Oh, like
discussed.
that is fine. I was just curious if there is something else that was.
Okay.
Yeah.
Yeah, I don't know exactly, but anyway. So yeah, back to this feature that I was talking about. So basically, if there are multiple schedulers that support preemption, they must be aware of the pods that they have nominated to run on particular nodes. Otherwise, they may step on one another's toes. And that feature is not there. So if there are multiple schedulers in a cluster that all support preemption, we may run into issues like one scheduler preempts pods on a node, and then once the resources become available, the other scheduler uses those resources before allowing the original preempting scheduler to use the resources. So this problem is going to exist, but hopefully we will address that soon as well. That's mostly about priority and preemption. Equivalence cache to beta, I let Jonathan, do you want to talk about it, or give a status
Sure.
update?
I mean, so the feature has been, complete for a long time, and we just wanted to sort of get the long tail of, bugs and cleanup and export the right metrics. Right now, somebody who I'm not familiar with came along and filed an issue on GitHub saying that they turned on equivalence cache and had a significant performance degradation. So they sent us a PR to hopefully reduce lock contention. But I think we were also going to see if we could reproduce what they saw and make sure, because the whole point of equivalence cache is supposed to be a noticeable performance boost.
Right.
So maybe their test involved, a lot of heterogeneous pods, or something is wrong with the hashing algorithm that we haven't noticed.
Yes. Do we have any benchmarks for equivalence cache? Basically, have we run any performance benchmarks with the feature enabled?
So there are overall scheduler benchmarks, and
I guess those are not going to be.
You could run them with equivalence cache turned on and turned off.
Okay.
I don't think anyone's done that, so we can at least collect that in like a more manual way. But it would probably do us well to explicitly have a test that enables and explicitly have a test that disables, so we don't need to go in and touch code each time.
Okay.
So the one that was used by a person who has reported it is scheduler perf, which is in test integration folder scheduler.
Yep.
And I was able to, I ran the test today. I did not collect any blocking contention data, but I will do it today again. But the numbers were kind of right, like with and without, there is some difference. Without being taken, without equivalence cache, it was taking lesser time.
So that's a serious problem as far as this feature goes.
Yeah, but I have scheduled like 10,000 pods on 3,000 nodes.
Yeah, definitely. Actually, I was talking with Jonathan yesterday or so, or maybe the day before. Anyway, I was telling him that given that equivalence cache adds a certain amount of complexity to the scheduler, and given that it makes maintaining scheduler a little harder, or maybe more than a little harder, because particularly we need to ensure that all the events and objects that are added in the future that could possibly require invalidation of equivalence cache are handled properly in the scheduler once they're added later. And all of this requires a lot of careful attention to many details. So given all these complexities, we would like to see a major improvement in the scheduling performance. By major, I mean something at least 20, 30%, or something in that order, or in the throughput of the scheduler. So if we don't see much of a difference, and of course, if we see slowdown, it does not make sense to enable it. And if we determine that this is not going to work, we should think about alternatives. I'm pretty sure with proper implementation, we should see a great performance improvement, especially when, for example, we go ahead and run some of these throughput tests or benchmarks that schedule a lot of homogeneous pods, which have the exact same properties in terms of scheduling. We should definitely see a huge boost.
So based on my understanding of equivalence cache, it has a much larger benefit when a pod does not fit, because then we would skip every other pod in the same class.
Right.
But that will never show up as throughput, except for every other job.
But it also helps when pods are schedulable, right? So when you, for example, evaluate a pod on a node, and let's say the pod requires one CPU, we evaluate it on all the nodes in the cluster, and we store the results.
Right, so we would only invalidate the data for the node on which it got scheduled.
And then the rest of the nodes in the cluster remain valid in the cache, so other pods that are scheduled with the same properties later, we can actually run the predicates. We skip running the predicates for all of the nodes that are cached. Harry, you wanted to say something. Please go ahead.
Yeah, because at the very beginning of implementing the equivalence cache, we actually did benchmark, and we can show at least 20% improvement in scheduler performance. But we have to create some special cases for, to see the benchmark results at that time, because we cannot just see improvement by using a default scheduler with some very simple pods. It should be the same. But at that time, there's no performance degradation because we only use a controller array to do the hash. We don't need to actually calculate a very complicated hash, and only a part group of the pods will be considered equivalent. So it's kind of different right now.
So if I understand you correctly, you're saying that we should create scenarios that we do more complex processing. Is that what you're saying, to see more benefits?
I mean, to create spatial pods, which actually you have mentioned with more properties in the pod specification.
Yeah, I mean, there are of course all sorts of scenarios. A lot of users may not put any sophisticated rules on their pods, but one thing for sure in a lot of Kubernetes clusters is that many users create replica sets, which have basically a lot of pods created from the same template, and they have the same scheduling requirements. Or deployments, which are all instances of the same template. So there are lots of these similar scenarios in many of the Kubernetes clusters, and we should expect we expect to see some performance improvement. So hopefully, with a little bit more investigation, we will know why we don't see that, and you can resolve the issues. Anyway, so hopefully this is still on track. If we can find what is going on soon, we can move it to beta. And I don't know what is the status of test coverage there. Harry or Jonathan, one of you guys can.
I think there's not much in the way of end-to-end tests. We're just relying on the existing tests, but I think the we want to specifically exercise,
particularly in validation. Maybe these could be more of like unit tests, maybe.
Right, and we've added. We added one unit test for that very specific race condition, for example.
Yeah. But have any of you guys, has any of you guys looked at the coverage and unit tests?
I have, but not recently. So I think in terms of basic functionality, I think there's reasonable coverage.
Okay.
And the real complexity is in these concurrency issues, and so it's less obvious where we're missing coverage.
Right. That's a lot harder to find out. Okay. All right, so thank you for that. Let's see, what else do we have? Yeah, I guess Klaus is not here yet. No. Yang scheduling, we are still designing this feature. One more person on Google has shown interest in working on gang scheduling as well. So hopefully this person will arrange with Klaus to work on the design, and we should, first step, we should finalize all the requirements for gang scheduling. We still feel we don't have a very clear understanding of all the requirements for the applications that need gang scheduling. We should hash out the details there, and once those are identified, we can have a more concrete design of the feature. And then we go to the next step of how it should be implemented, whether it makes sense to implement it as a separate scheduler or put it in the same scheduler. Do we need a different controller for gang, and adding like new pods to the gang, deleting the gang when the number of instances of the gang drop below a certain minimum. Sorry, go ahead.
Bobby, I'm just wondering, like, for initially, we can just can we just make it simple, like, just say like there's only one game can be scheduled at a time, and initially, like, let's just make a deadline. If it exceeds the deadline, like say 1 hour 30 minutes, and it just tells, I suppose, in the status, say this thing failed, and then pick the next.
So let me understand better. So you're saying that gang can be specified from a single template, right? For example, say this is like a replica set that we have. For example, we have one template for all these replicas, and you say there is just one single sort of like template for all the instances of the gang, and then there is a minimum, and you give it like 1.5 hours. So where did this number?
So for example, like the gang, for doing gang scheduling, we need to like reserve the resources, right? But like reserving all those resources is just wasting like resources and keeping other parts from being scheduled. Mm-hmm. So let's say like I'm trying to schedule a gang of like one parameter server and 2 workers, and now I only have 1 pod slot. I need additional 2, but like now I'm just reserving the one. But let's say I have a deadline, say 1 hour, and if after 1 hour like this thing still cannot be scheduled, I will just mark this gang schedule and this gang is fail, and also release the resources that I reserved before.
It works fine. Something like this, it works fine as a proof of concept or for prototyping purposes. But I highly doubt if the community accepts adding something like this as a feature to the scheduler. When we think about adding a new feature, we should think about the proper APIs, instead of just hard coding like 1 hour or whatever number of minutes that you want to think about. We should probably add a way for the user to specify the timeouts for the gang. Also, we need to specify, for example, whether the gang is going to be always like run to completion, which seems to be the case most of the times, or do we support long-running services as well as a gang? I'm not so sure, not convinced. That none of us see any use cases for like running the long-running services as a gang, but we don't know yet.
Actually, like we are trying to run like long-running services as a gang. It doesn't matter. Like
by long-running, I mean something that never finishes or never is supposed to finish. Like, for example, a web server or a database server. Do you run such services as a gang?
Actually, we run like stateless services as a gang, but it's just more of a convenience for scheduling a lot of parts. Like, for example, we have a set of things that we want to like schedule together. For example, our user had a lot of parts, stateless web apps, which is basically they are trying to like run them like on different nodes, and in order to do so, like doing a gang scheduling seems just works for this case. But this is different. Like for this case, we don't actually need a deadline. Like if the GAN fail, we can just mark it fail. But like for the other case, like machine learning jobs, we definitely would, it's definitely batch jobs, and we need a deadline. Like that's our use case.
May I ask a question? In your example, does the application function if half of the pods get scheduled?
No. This won't work. Like that's the thing. But like currently we can work around that. Like we build another layer on top to like say to just like keep trying, and like because it's one time thing. Like if we detect some of the things that doesn't get scheduled, we just mark it fail. But like it's just not native enough, and it seems like case also fits into the GAN scheduling use case.
Interesting. So is this a particular like custom service that you guys have, or you can tell us what it is?
Oh, it's like a bundle. Like so like from a user perspective, he tries to like create a bundle of apps, and you just click create, and all the way goes to the end and to the kubelets on different nodes, and just everything gets created together, or none of them.
Are you talking like running WordPress plus a database kind of concept?
Yes, I would say so, but like like for those cases, you can run it on the same node. Like here, we just guarantee you run it on you're just trying to spread it out.
I don't know if Yang scheduling is going to help you much with that. I mean, at least so.
No, so I'm not saying like this GAN scheduling is like specifically designed for this thing. I'm just saying like you're asking if GAN scheduling would work for stateless services. It's like long-running services. I'm just telling like we have use cases more than beyond batch jobs. But definitely like, the machine learning jobs and batch jobs is one of our use cases as well.
Okay. Yeah. Well, again, this also.
We should make sure that we get you looped in on the discussion for the design doc.
Yeah.
Either on the mailing list or on the, I don't know where.
Yeah, exactly.
Could you please create an issue to explain your user case, Hong Chao? I mean, so you can see your requirement.
Excuse me, can you repeat?
I mean, can you create an issue to explain your user cases so we can discuss it further?
Yeah, definitely. Yeah. So
yeah, please.
Yeah, sure.
Or I guess maybe there are shared design docs. I don't know if they are all shared with the stake or not, but if there are shared design docs, you can comment on those docs as well. We would like to hear all these feedbacks. One thing that I've heard multiple times in various contexts is that heterogeneous pods are needed for gang scheduling. Basically, gang that has different pods with different images. That's something that seems that we need to support from the very beginning. We would like to hear some of these other feedbacks, like whether we need to support long-running services or just batch jobs. How do we handle the case that the number of replicas go below a certain number? Oftentimes we think that we should kill the gang, but some people believe that we should give it some time before killing the gang. And all these requirements that different people have. Basically, we would like to hear all of those before we can make a final decision about how to proceed and build this feature. So we're running out of time. I would like to quickly tell you a little bit about pod scheduling policies. That is another feature that we are designing. There has been lots of different opinion about how we should design pod scheduling policies. Some people believe that we should use OPA. Some people believe that we should design API in one way or the other. So there has been a lot of discussions over there. It is still kind of in progress. We are hoping that we can reach to consensus soon on that area as well. So these are all the updates that I wanted to give you. So if you have any more questions, please go ahead. We have like several more minutes.
Sure. So I'm just wondering, like you're talking about like the design doc, like is the design docs being published somewhere, or can you share?
I think that's with Klaus.
Yeah, I don't know. Klaus has written one design doc. I don't know if he has shared it with the whole SIG, or do you know?
Last time we talked, he had not yet shared it, and he was
Okay.
planning on doing it soon
Okay.
after he got some initial feedback. So maybe this week or next week we can share that, or I don't know.
Yeah, and one thing that I would like to say about the design docs, I don't know if it matters for the people who are currently present in the meeting or not, but anyways, I get a lot of questions about, or a lot of requests to access to various design docs that are created on Google Docs. When we share those in the SIG or with the community, you need to be able to access them if you are a member of Kubernetes-dev Google groups. That's how almost all these Google Docs, which are made by various members of the community, shared. So if you see that you don't have access, please make sure that you are a member of that mailing list. It's Kubernetes-dev. Okay. Is there any other question?
So, Bobby, what do you mean by the scalability tests? Are they same as the scheduler perf tests? Are there any different tests?
So these are usually the tests that the SIG scalability has. They are end-to-end tests. They launch a large cluster usually and run a lot of pods, usually with the same like, properties in the cluster. They are not exactly the same as those scheduler performance tests. Some of those might be similar, but they are not exactly the same.
Okay. Do you have the GitHub location or some other place where?
Yeah, I can send them to you.
Sure. Thanks.
Okay. Any other questions? You're almost right on time. If there's no question, we can end this meeting and see some of you guys next week. This Klaus just joined. Hi, Klaus. You are muted.
Oh, sorry.
That's
late.
fine. No, that's fine. We were wrapping up this meeting, but we had some discussions about gang scheduling actually.
Yeah.
And maybe you can give us a quick update on the status of the project.
Yes, I think I have a draft design document here about the gang scheduling, and I think we have some internal discussion because there are several options here between we need to do some scheduling based on a pod group to do that. I think there may be some enhancement of interaction with the current features in scheduler. So I think there may be some discussion here, and it's ongoing. I think we are going to try to publish it as soon as possible, but I think we would like to get an overall agreement before we publish to the community. So too much discussion maybe got the other user confused. So yes, we will try. Well, we try to do that as soon as possible.
Yeah, I was actually telling everybody that we need to collect all these requirements. There are different ideas about what should be done for gang scheduling. Actually, it's not a bad idea if you share the document with the community, with the SIG at least. And then people will have a chance to say what they need in the gang scheduling. For example, we were thinking that probably gang scheduling would be a feature suited for running batch jobs, basically those jobs that run to termination. But today we heard that it might actually benefit some of the long-running services as well, and some people may need it for long-running services as well. The other day, I heard at KubeCon and some other places that people are interested in running heterogeneous workloads in a gang, basically a gang that runs pods with different images, not necessarily the same single set of image.
Yes, I think we also got the requirement from TensorFlow and Spark. Yeah.
Yeah, exactly. So it's not a bad idea if you share your document with the community, and then we collect all these requirements and incorporate those changes into the design, and then we go from there.
Okay, sure.
Okay, thanks a lot. So we are going to see you, or some of you guys, next week.
Okay.
Bye for now.
Okay, bye.